solution to example 15 from notes 6.1 days 1 and 2. And this is a problem where we're going to be converting from angular speed with different units and from angular speed to linear speed. And we started this in class, but I wanted to just review it a little bit and then do part C and D completely, just so that everyone understands it a little bit better. So here we're given the context that we have a circular mobile above a baby's crib, and it makes 5 revolutions per minute. This 5 revolutions per minute is an angular speed. We know it's an angular speed because it's talking about how many turns something makes per minute. It's a rate of change in angle per unit of time. Right? So we're given that in revolutions per minute, and in part A, we're converting to an angular speed with different units, which is radians per second. So we're converting from revolutions per minute, 1 unit of angular speed, to another, radians per second, where both are angular speeds. And we did that conversion in class. In part B, we're converting, we start with an angular speed, and I started in class in revolutions per minute, and we convert that to a linear speed, which we were asked to give in feet per second. So the linear speed is actually how many feet the toy, which is 9 inches from the center, travels per second. Okay, so this is linear speed because it's units of distance per time. I'd like to do letter C now. We didn't do this one in class. Part C says, how fast is a toy 6 inches from the center traveling in feet per second? So it's almost the same problem as in letter B, so it'll be a good review. But now we have a toy that's 6 inches from the center, and we want to know how fast it's actually moving around the circle created as the mobile spins. So the way I recommend doing these problems is start with what's given. So we're given that the mobile has an angular speed of 5 revolutions per minute. That means it spins around 5 times per minute. So we want to convert, this is an angular speed, and we need to convert that angular speed into a linear speed. Eventually, we want that in feet per second. The key to converting from angular speed to linear speed is to know how far does the toy travel per revolution. So in 1 revolution, this toy travels around the circumference of the circle. So in 1 revolution, it travels 2 pi times r, which is 6 inches. This is the circumference. Okay, so when you're going from angular to linear speed, 1 revolution equates to traveling the circumference of this circle. And now I can cancel out the revolutions, and I have a linear speed in inches per minute. I'd be done if I just wanted to get a linear speed, but I want a linear speed in feet per second. So now I have to convert the rest of the units. Okay, so I have units in inches. I want it to be in feet. So I can say there are 12 inches per foot. That's a funny form of 1, really, just scaling the units. My inches are gone, and now I have my answer in feet per minute. I don't want it in terms of minutes. I want it in terms of seconds. So I can say in 1 minute, there are 60 seconds. I can cancel out the minutes. So now my units that are left are feet per second. Okay, and then let's simplify this answer. So we would have 6 times 2 is 12. So I can cancel out the 6 and the 2 with the 12. That would become 1. So now I have 5 in the numerator. I can cancel out the 5 with the 60 and make it 12. So I'm left with pi over 12 feet per second. And if we really want a decimal approximation, that's about 0.262 feet per second. The answer that we got in class for part B was pi over 8, I believe, or 0.392 feet per second. When we compare these two, it should make sense because the toy that's traveling at a radius of 9 inches is going faster in terms of linear speed than the toy that's traveling at 6 inches away from the center. And this is like the ice skating example that I talked about in class. If we all held hands, the person closest to the center would be traveling slower than people further out. They'd have to be traveling faster, even though they all have the same angular speed. Let's do part D. What is the linear speed of a toy directly at the center in feet per second? If something's directly at the center, the radius is 0. So if we want to, we could go through the entire calculation. So we could say we have 5 revolutions per minute times in each revolution, the toy travels 2 pi times 0 inches. Oh, I'm sorry, it's not inches, it's feet. Right? And that means that our result is going to turn out to be 0. So it's going to be 0 feet per second because the toy is not moving linearly. Right? It's not moving linearly. It's only rotating. So it only has angular speed, but no linear speed. Okay, so I have a little note here. Notice that even though all the toys on the mobile maintain a constant angular speed, right, that's the 5 revolutions per minute, throughout their journey, the linear speed increases the furthest the toy is from the center. Okay, so the toy at the center has an angular speed. Its linear speed is 0 because it only rotates. And I suggest you read this interesting note about different tire differentials.